Hello guys and welcome to my channel. I'm David. I've been a software developer for about 15 years, mainly coding in Java and Scala. I taught myself the blockchain technology and how to build app, and on this channel I'm going to show you real-world use case scenarios of the blockchain by coding concrete applications. If you're new here and like the content of my videos, please subscribe to the channel and click on the like button. So what you see on the screen is the app that we are going to build to illustrate the use of the Uniswap library to swap tokens. We will deploy this app on a fork of the Ethereum mainnet on our local machine with the use of Ganache. Ganache is a software that is used for running local private blockchain, used mainly for development and testing purposes. The front end of the application is based on React, which is a JavaScript front-end library, and we will build a smart contract that swaps tokens for our front end to interact with. A smart contract is like the back end of your application, and you can store data and transfer money to and from smart contracts. Our smart contract will allow us to swap Ether to USDC token, and for that, we'll make use of the Uniswap V2 library. So to start, you can go to my GitHub page and copy the link to clone the starter code. So click on this project, Uniswap V2 DeFi app. Here, you can either clone it, so you have to copy this URL, or you can download the zip file. So let's go to our command line and we will enter git clone with the address we copied from GitHub, from my GitHub page. And then we cd into the clone directory. Once you're here, you can just do npm install. This will install all the dependencies that are defined in package.json and contains all the dependencies you need for the project. Now you can change the branch. If you want the starter code, you need to do git checkout starter. So once we've installed the dependencies, you get a node modules. That's where all your dependencies are downloaded. So now let's run the app. To run the app, you just do npm start. And you should see the app running on your browser. So that is the running app that you get once you do npm start. As you can see, all is hard-coded. All those values are hard-coded. It's just dummy data. So now what we will do is develop our smart contract and connect our front end to our smart contract via the Web3 library. So let's continue. So now we will create our smart contracts. To create our smart contracts, we'll first need to initialize a Truffle project. You get the Truffle dependency from the starter code and the npm install command you did earlier. Truffle is a framework that is built on Node.js and that manages the development lifecycle of a decentralized application. It is used for compiling, running tests, and deploying your decentralized application. It also has a console through which you can interact with your deployed smart contracts. To initialize a Truffle project, you need to enter the following command on your terminal inside your project directory. So npx truffle init. And initialization is successful. So you get new files and folders in your directory. You have a Truffle config file, a contracts directory, that's where you will create your Solidity smart contract, and a migration folder and a test folder too. The migration folder is where you have your JavaScript files that will be used to get our deployed contract. So we'll see how to create that. But first we'll see how to configure the Truffle project for our local environment. So let's get back to our code editor and see how the Truffle config file looks like and how to create the configuration for our local development environment. So by default, it's got a lot of things commented. It's useful to read it. It's got a lot of information, but we will remove everything just to be clear. I will leave in the network section, I will leave the development part. This is what we need for local development. Other network are defined. Maybe here we have Ropstein network. So if you want to deploy your contracts on the Ropstein network, you can uncomment this part. But we will just work on a local environment, which is called development by default. It's configured to be used in localhost, and the default port is 8545. We will change the Solidity version, so we'll change the Solc compiler version, and we'll optimize the compiler. So the settings here, let's uncomment. Let's uncomment the settings, optimizer, and let's enable it. And also I want to configure the port I want to run my local Ethereum network, private network, on this port. And another thing that I want to change is where Truffle will output the compiled file. So for that we will need to specify the build directory. By default, it will output it inside the contract directory, if I remember well. Oh no, it will create a build directory by default at the root of your project, and it will output the compiled file inside this build directory. But if we let this default behavior, it will be a problem for our React application to access those files, those compiled files. So we need to change that, and we need to output the compiled file inside the source directory. So that's how we can do it with Truffle, with the Truffle config. I make use of the pass library, which is included in Node.js. And their name is it's a global variable that is used, and it's the current directory. So I want to output it in source ABI folder. In source ABI folder, that's where I want all my compiled smart contracts to be. Just a comma here, save the file, and that should be fine. So some other things to talk about Truffle is that the created contracts and migration folder, inside you have a migration script, JavaScript file, and here you have a migration contract. This is used internally by Truffle to keep track of the migration you are doing for your smart contracts. So do not remove those files. Those are useful for Truffle when you will do migration yourself for your contract. So now let's see migration in action, and let's create our first contract. So our first contract will be an ERC20 token contract. It will represent a USDC token that we will use in the app. For that, we will we'll make use of the OpenZeppelin library, and we'll extend their ERC20 token contract. So we first need to define the version. And we're using 0.66 because Uniswap is also using this library, so we need to have compatible version. Now we will import the OpenZeppelin ERC20 token contract. Don't forget a comma here. So to extend a contract, you use the is keyword. And you can override the constructor. And you give the name to the coin and the symbol. And that's it. That's our first contract. So let's create the migration JavaScript file. So the migration scripts are numbered. This is also important and you should respect it. The first is the initial migration. This is internally used by Truffle. So we need to create another script which will start with 2, and we will call it deploy contracts. .js, and inside we can just copy this and replace the name of the migration contract by our contract. And that should be fine, that should work, so we can try it with the Truffle compile command. So let's go to our terminal and type npx truffle compile. And it looks like it was compiled fine. We see here my contract. It was actually compiled. Artifact written to source ABIs like we defined in the Truffle config file. So let's have a look in our code editor. So in the src folder, ABI, and it has compiled other unnecessary file actually, because we import in our contract. We import the OpenZeppelin contract, so it also has compiled this and its dependencies too. So we can just remove it. And that's it, guys. We have compiled our first contract. Now let's code our second contract, which will be a decentralized exchange smart contract that will make use of the Uniswap V2 router. So let's see it. So let's create the Solidity file, and we will call it. So that will be a very simple decentralized exchange. It will just do a swap, that's all. So we start with the version, like before, and we use the same version. We import the Uniswap library. So the first thing we can create in our contract is to give it a name. And let's call it DEX for decentralized exchange. And next we need to import or to use the Uniswap library to have a handle to the router, to the Uniswap router. The router will allow us to do the swap and also to get the rate of the token, the exchange rate of the token. So to have to make use of the router, we need to find its address on the mainnet. I found it just simply by typing in Google Uniswap Router V2 address, and the first link will be a link to etherscan.io with the address. So I will simply paste it here. So that's the address of the Uniswap V2 router on the mainnet, because we will fork the mainnet to have access to this smart contract. We also need to have a handle to the USDC token, so we need also its address. And you can find the address of the USDC token on etherscan.io. You can simply type USDC and it will show up the address. And that's the address here of the USDC token on the mainnet. So next, let's create our constructor. And the constructor needs to be payable, because we will transfer some amount of ether to this account, to this contract. So you need to make it payable. And here we simply instantiate our router. with the address of the router on the mainnet. That's it, guys. That's how you make use of the Uniswap library. Import the router and instantiate it with its address on the mainnet. So next, let's see how we can create a swap function. So we'll need a function to swap Ether. So let's call it swap ETH for USDC. And I want to pass in the amount that we want to swap. And it needs also to be payable because we will transfer some ETH from it to it. So let's see how we can use the router inside this function. And let's check out the Uniswap documentation. Here we are on the Uniswap documentation page. So we can have a look at the technical reference, and here you find Router V2. And there is a bunch of swap function for smart contract. I will use the swap exact ETH for token. So swap exact ETH for tokens. That's the function I will use. And here you can read the explanation. Swap an exact amount of ETH for as many output token as possible. And we will transfer the amount of ETH with message.value. And that's why we need to make this function, to declare this function payable. And the amount out mean, this is calculated by another function from the Uniswap library. And you can have a look at it here. That's what I will be using in the contract. And that's this function here. So you can have a look at this documentation and read about those methods. That's how I will implement the MySwap function. So let's code it. So let's write this function. So we've seen that we need to give some Ether with the value parameter. And then the other parameter were like this. There was the amount out mean, the path, the sender. So this will be, to whom we want to send the token. So that will be the message.sender. And deadline. Again, you can refer to the documentation that I've just shown you to see what all those parameters are. But the deadline, for simplicity, I will just use the block.timestamp. And the pass, for the pass, I will define a function. But let's first declare it here. So that's it. Now let's create this function. Get ETH for USD pass. function here. So the router has already defined the width constant. So that should be fine. If you want to understand this exactly, you need to refer back again to the documentation. That's the path that is required by the Uniswap Router swap exact ETH for token method. So let's do the same, because we'll need to swap from USDC to ETH. So let's just do the same right now. And we just invert this path. So that should be fine. Let's also copy this, and we will do the swap for USDC for ETH function. So here will be so here the function from the Uniswap router is swap exact token for ETH function, and the parameters are a little bit different because we don't send this parameter, and here actually okay, so that's it. One important thing to do also is to give allowance to this contract to spend our tokens. So one important thing to understand is that we need to transfer token to this contract and give allowance to this contract to spend our token on our behalf. So I will just show you how to do this right now. It's pretty simple. You need to do like this. So you need to call the transfer from a function from ERC20 token with parameter message.sender. The address, it's the address of this contract, and the token amount. So that means we send from our wallet to this contract the token amount. And then we need to give allowance to this contract to spend those tokens on our behalf. And that's it for this function. That should be fine. and I think that's all we need for this swap contract. Okay, now let's start to code our front end. So back to our command line, let's recompile our contracts, and we'll see if there is any errors, and I'm sure there is. And yes. So the address is not in a proper format, so let's put it in the right format. So I copied it again from Etherscan. So let's compile again. Oh, I didn't save. Okay, and now it's compiled successfully. So let's see how to deploy our contracts on our local machine. For that, we will make use of Ganache. It's already in your dependencies, so you don't need to do anything more. If you did already npm install, you will have access to it. With Ganache, we'll fork the mainnet, so we will make a copy of the mainnet in our local environment. So that can be very handy for testing purpose. Development and testing purposes. We fork the mainnet because we want to make use of the Uniswap contract that's deployed on the mainnet, and also the USDC token. So in order to fork the mainnet, you need the Ganache CLI, and you also need to have an entry point to a node in the mainnet. So you have several ways of doing it, but the easiest is to use the Infura API. Infura is an Ethereum node as a service provider, and once you register to their website, they will provide you with a private key that you can use with their API to access the Ethereum mainnet and the testnets. So the link to the Infura website is provided in the README file of the project. So you can check my GitHub page for of the project to get the link. The private key that Infura will provide you is personal and should not be revealed. So for that, I will make use of the .env package to access this private key via environment variable. This is where I make use of the .env package, and we import also Web3 because I want to print the list of the account that are created by Ganache. They are test account. You can also use Ganache CLI with the command line. But I'm using the script here. I'm using a JavaScript file so that I can use the .env and access my private key with the environment variable. Here is the address for the entry point to the mainnet provided by Infura. Okay, so that's how I make use of the .env package to access my private key. So next parameter, we will unlock an account. I've checked that account in etherscan.io. It's an account that's got a lot of USDC. Yeah. So let me copy the address. Here we will output the account keys that are created by Ganache. Because it will show the private key, and this can be useful to if you want to import account into MetaMask. And I set a seed so that I always get the same generated account. Okay, so that's the options that will pass to the command. So if Ganache has started properly, we should see this output. Here I will instantiate the Web3 library. And finally I will fetch the account with the Web3 library. Okay, so if everything was fine, we should see this output on the screen and the list of accounts. Let's save it. Now we need to make use of this command. We can add it here in our package.json file where the script section is, and you can call your command Ganache. And actually it's a node command, so you can just call it like this. And that should be it. Let's test it on our command line. So for now, let's stop the React frontend and let's start Ganache with the script we've created just before. Yes, it's looking good. We see the console output that we expected with the list of account, so that should be fine. Let's keep going and deploy our smart contracts. To deploy our smart contract, we need to issue this npx Truffle migrate dash dash reset. Oh, actually, we didn't complete the migration script. So let's do that now. So now this deployment script will get a little bit more complicated. Let's change the name first here with the name of our contract. So we will need to create the DEX contract with 10 Ether from the account that will deploy the contract, which is the first account in the list of accounts provided by Ganache. That's by default the first account is the one that will deploy the contract. So we will use this account, and it has 100 Ether. All accounts created by Ganache have some Ether. So by default it's got 100 Ether. So we will transfer 10 Ether from that account to the DEX contract. And then we will also need to transfer USDC from the unlocked account to the DEX contract. And we will also need to transfer USDC from the unlocked account to a user account. So we have some USDC in the contract, and in the account that will be the user, it will have also some USDC token. So let's do this. So for that we'll need the USDC, the address that we have defined in the contract here. So we will need this address, the USDC mainnet address, and we will need the unlocked account address also. So let's do that. Let's copy it from here. Okay, and let's copy the unlocked account address. Now we will not deploy our contract, but we have we will make use of this address. So we will change this deployment part here. We need to make this function async, and we can directly create the USDC contract in this way. Like this. Here we will create DEX contract with 10 Ether from the deployer account. So that's how you do this. That's the first account, the deployer account. From the list of accounts that we actually got here as a parameter, and we will give 10 ether. So that is 10 and 18 0. Then we can deploy our decentralized exchange contract. So to transfer USDC, you need to use the transfer method. And let's transfer 1000 USDC. That should be fine. Okay, let's transfer it from so the user account for us will be account number 2 in the list of account provided by Ganache. And it's the same command. Transfer method, the same method. And from the unlocked account here. Okay, that should be fine. Let's deploy it now. So let's issue the command to do the migration. We have Ganache running. This is important. Ganache must be running. And the command is npx truffle migrate. Okay, and migration went fine. So the contract is deployed. So now let's make use of our contract in our front end. Now let's try to connect MetaMask to our local blockchain. And we should be able to see the account number 2 with the right amount of USDC token. So we can connect to our MetaMask on our local blockchain. And I have already imported this account, which is account number 2. And we can see that we have 1000 USDC token and 100 ETH. So our fork is working fine, our deployment, our migration is working fine. So now we can plug our front end to our smart contract with the use of the Web3 library. So guys, this is the final part of the app where we will fill the gap between the front end and the smart contract. So let's get started. So let's first take care of the balance that we have here. Let's have a look in the code. So here is the code for the front end. So we have our component here, wallet info, where I have hard-coded the values here. So first let's take care of that. We will pass the value via props. And let's change it here. For that, we'll make use of useState React hook. Can give it a value of 1 to start. Here we go. Save that, save here, and there should be no change now in our front end. Let's check it. Yes, so still 1, and here it's working. We are passing our props here. So now let's take care of the swap methods. So we will need to import a few dependencies and Web3. And we'll need to import our smart contracts, which are located in the ABI folder here. And similarly for the token contract. So that's fine. We also need to have, we'll create a constant to have the USDC token mainnet address. So I have it somewhere here in the migration script, I think. Yes. Let's import it here. Yes. So now let's initialize the Web3 library. We will do that using the useEffect hook. So I'm importing it from React. So this use effect hook will run only once once the components are loaded, once your page is loaded. So it will execute only once. So let's create this load Web3 function. So if MetaMask is installed, you should have this provider here, window.ethereum. And here I'm just following the guidelines from the MetaMask website. So we instantiate the Web3 library by passing it the MetaMask Ethereum provider. I want to set the Web3. Okay, so that's when our page will be loaded, it should request MetaMask to open its window, and we'll be able to log into MetaMask. Check other videos on my channel for more explanation on how to connect to MetaMask via Web3. So let's refresh the app and we should see MetaMask popping up, asking us to enter a password to connect. Yes, that's it. It's working fine. I will not connect now, but we have the pop-up. So the load Web3 function is working properly. Web3 is initialized correctly. Now that we have our Web3 library initialized, I want to load the data from the blockchain, from our smart contract. So let's use another use effect hook here. And I want it to be called when Web3 that we have defined here is updated. So at first is like empty, it's null. And here when I do set Web3, then this function use effect will be called. Okay, let's try it in our browser. So back to our app, let's refresh. We have the pop-up, let's log in. And yes, it's working fine. I have one account selected here. So, okay. Let's see what we have here. Okay, we have our load blockchain data, which is called. So that is fine, it's working fine. Let's see how we will load the blockchain data. Back in the code editor, let's remove this console log. I want to check here if Web3 is initialized. Then we will fetch the account. I will call it the account that we are connected with on MetaMask. I just call it investor. I want to have it as a state. Okay. Now let's check the balance. So that's the method to call if you want to get the Ethereum balance of an account. And then I can do and actually if I do it like this, it will display the balance in way, because here what we get is the balance in way, but let's see how we will format it later. So now I want to instantiate the contract for my ERC20 token. So let's do it. So we need two things to instantiate a contract. We need the ABI of the smart contract, and we need the address where it is deployed. So we are using the mainnet address for that, and the ABI that is taken from the JSON file that we imported just before. Here I can get the ABI in this JSON file. And the address is this one. USDC token on the mainnet. So let's take this here. And then I can have a state for this contract too. Let's instantiate it with an empty object. So once we have the token contract defined as a state variable, we can try to get the balance. So that's how to call this method, balance off. It's available on all ERC20 token. So I'm asking here the balance of the investor, the USDC token balance of the investor. And we can save it in a state variable too. So we can refresh our frontend properly. So actually we defined it in the beginning, so that's fine. Set token balance, okay, it's the same, okay. That's fine. So actually let's see if this is working. So let's save it and check our web browser. But first let's run Ganache and redeploy our contract. Okay. Has recompiled everything. Let's delete it again. Okay. Let's go to our browser and let's connect to Ganache. Okay, we see that for this account we have 100 Ether and 1000 USDC. Let's refresh our app. And yes, it's fine. Yes, it's fine. So it's displayed in way. So we'll see how to format it later. Now let's create the decentralized exchange contract. So we'll type the code and explain it to you just right after. So here we are fetching the network ID through which was deployed our contract. So this is similar, almost similar to what we did for the token contract. We need to pass the ABI and the address. The difference here is that we have deployed this contract, DEX contract. So we get the ID of the network, and we look at the compiled file in the network section and get the address that is used for this network. So we can have a look here. Actually, in the compiled file we have ABI, and we must have networks here. Okay, network ID 1. This is the main net, because we are using a fork of the mainnet. So that's the network ID on which the contract is deployed with Ganache, and that's the address to where it is deployed. So we are fetching this address, and we can create the contract here with the address. So now let's set the state variable. Just here, let's call it like this. Okay, token contract. So let's do the same. So that's it, guys. Here we can display some message if we want. If we don't have data, that means the contract was not deployed properly. Okay guys, that's it. Let's see how to use the contract now to do the swap. So let's start with this one. Let's use the async await pattern. So we can simply just call it directly here, call the smart contract method. How did we call it? Let's check again. Swap is for USDC, okay. And here, let's first just do one Ether. And here we are sending a transaction, so we need to use the send instead of the call. When you just want to read data, you can use the call like we did for the balance. But when you want to send a transaction, you need to use the send method, and you can pass here the value. And the from, so we use our investor. Okay, on swap, yes, because here, yeah, for now let's use just one Ether just to test, because there is no properties. We cannot read the value that I put in the text field, so now for now let's just use one Ether. And let's just check the balance after. The Ether balance. So it's the same method as above. Let's get the token balance too from here. Okay, set token balance. And set is balance. Okay, let's implement the swap USDC handler method. It will be similar, but we will call the other method from the smart contract, the other swap method from the smart contract. The difference here is that we will need to give allowance to the smart contract to spend our tokens. So we already did that here. Here we are sending the USDC token amount to the contract address from the message sender, and here we approve the router to spend our, here we give allowance to the router to spend our token amount. But here we will need to give allowance to this smart contract to use our token. We'll need to give allowance to this smart contract to use our token. So let's see how to do this. This is the difference with the call to this method, to the other swap method. So we need to fetch again the address from the smart contract. So we do like this. Okay, but we will not create the contract again. Here we will approve. We will give allowance to the decentralized exchange contract to spend some amount of token on our behalf. So let's give allowance. And I want to give allowance for 1000 token. USDC token has 6 decimals. Let's create a constant for that. Okay, now let's give the allowance. So yeah, we give allowance to this contract to spend the token on our behalf. Here, this amount of token on our behalf. Then we can call the swap method. Let's copy here. Oh, actually, this is an object. Okay, let's get the balance now, the same as here. Okay, let's test it. Check our web browser. Let's do a first swap here. Let's refresh. Let's do a swap. Okay, we transfer 1 ETH. Let's confirm. And yes, it has done something. We will display it differently. Let's display it properly. Here, okay. Oh, no, actually for token balance, no, because it's not the same number of decimal than Ether. So we have to divide it by that should display the things properly. No. Here we have to change it also here, up there. Here and here. Token balance, it balance, and yes, yes, that looks all right. That looks all right. Okay, let's swap. Let's swap USDC. Okay, confirm. So guys, I have tried to do the transaction, a swap USDC transaction, and I realized there was a mistake in the contract. So here it was a copy paste mistake. The path was wrong. Get ETH for USDC. It should be, because I copied the method from above, it should be get USDC for ETH path. Okay, so now let's try. I need to redeploy, restart Ganache, redeploy. And now everything hopefully should run smoothly. Okay, here we have the right amount. So let's swap ETH first. Okay, we have less ETH and more USDC. Let's swap USDC. And this is where it was failing before, and now it's fine. Now it's fine, perfect. Let's try to put the amount here. So guys, now let's try to add the functionality that will allow us to enter the amount of ETH or USDC that we want to swap. So let's first create two state variables. Let's add here the method that we want to call in our component from the props. And here we will just set the ETH amount, entered. And we don't need this async here. Okay, and let's use the amount here in our swap method. And in the here too. And in the swap USDC method. So instead of 1000, it will be token amount. Okay, that should be fine. Now let's update our components. So here input, it will be the onChange method. We get the input value here, and then we call the method from the app component, from the parent component. And how did I call on ETH entered? Okay. And that should work. Let's do the swap USDC component. And we call the parent component method with the value. On token entered, on ETH entered, and yeah, that's it. That should work fine now. Let's try. Let's go back to our web browser. Okay, let's enter 2 ETH. Okay, we have 2. Seems to be working as expected. Okay, and here let's swap 5,000. So that's it, guys. You can improve the front end still. You can remove this after we did the swap. There's still a lot of improvement to bring, but This is the basic functionality of this app. So thank you. If you like the video, please subscribe and press the thumbs up button, and see you later, guys.